Hello guys, welcome to today's video. So in today's video we are going to see about what is Docker, why it is so popular, and we'll see how we can achieve Docker in our local machine. Okay, so before moving on to the session, first let's see why do we need Docker. Basically Docker is nothing but it's a tool. It is one of the tool for containerization. Containerization. Now you might ask the question, what is containerization? So we will cover this shortly. So containerization is nothing but so if you take a development software life cycle, so there will be a development team and there will be a testing team and we have a production team. Production team. So if you take a software, it might have three stages. Okay. So first development team will develop their code, like they will write their code and they will share their code to the testing team to check on different test cases. So they will share their code. So for example, uh, so in developers team they are using Node version 10. So they are using the Node version 10. So while checking here, so this code is running well. This code is working fine in developers team. So they thought that so it's working fine. So let's share this code to testing team to test on different use cases. Okay, so they share their testing source code to testing team and testing team will download their code and they started their testing. So while checking, so assume that the testing team is having Node.js version 11, which is they are using latest version, but here they are using version 10. So while using version 10, the DevOps team will couldn't find any error, so it's working fine in their developer team. So here they are using version 11. So while checking, the code is not working. So testing team will tell you have a problem in your code. It is not working well. But while checking in developers team, it is working fine. So there might be a slowdown in the software development life cycle. Okay, so it will make the software development slow down, right? So to overcome this problem, so so the main problem is there is a mismatch, there is a version mismatch. So that is we have a version 10 here, we have 11 here. That is what the main problem. So so it will slow down the development process. So to overcome this problem, so we have a technologies called containerization technologies. So containerization is technology is nothing but so here they only shared their code. So in containerization technologies, so they will share so what are the softwares they are used to develop this application. So what are the softwares required to run this code. So like think of container is nothing but it's like a box. So what we see in the road, right? Container truck. So it's like a box. So basically they will put their code and then what are the softwares needed to run this code. Like in our case, we will have a Node version 10 and some dependencies required to run this source code. So they will put dependencies and other softwares, other runtime environments. They will put everything. It's like a packaging everything into a one unit. That unit is called nothing but container, and share their container to the testing team. So here there is no we have a no problem that it might not work in. So it will work, it will definitely work because there is no mismatch version. So we have everything, just they have to uh, pull the container and they have to start their testing on different test cases. So here we don't worry about whether it might work or not, we are whether it might having problem or not. So it will work fine because we have everything that the software needs to run. And once they completed the testing, they will move share their container to the production team and they will check whether it is working or not and they will deploy it in a server. So it allows us to develop the software very quickly. So this is the main advantages of containerization technologies. Okay, so let's see. So let's say Docker is nothing but, so it is one of the tool to package our application. So we have a many technology, we have a many tools. So Docker is one of the most popular tools we are using in day-to-day world. Okay. So let's see what is Docker. One minute, guys. I think you will be able to see. So let's see the book is answer what they are telling. So Docker is a software platform that allows you to build, test, and deploy the applications quickly. So as we see earlier, here we will see, right? So we will develop the software quickly using Docker. So Docker package software into standardized unit called containers. So think of containers as the box, okay, that having everything that the software needs to run, including libraries, system tools, code, and runtime. So in, in Docker we can package our application like we can put libraries, system tools, code, and runtime, everything into a single unit. A single unit is nothing but containers. Okay. So before Docker, they are using the virtual machines. So let's see the difference between virtual machines. So this is a host OS. Think of host OS is nothing but it's a local PC. And here also we have a host OS, and here hypervisor. Hypervisor is nothing but it's a software which allocates resources, which allocates resources for this operating system. So this is like a virtual machine is nothing but it's like a digital version of the computer. For example, uh, in your local machine you have a 8 GB RAM and a 500 GB hard disk. uh, you can create another machine like inside our physical machine you can create a virtual machine. So this is like a, it will be same as like a physical machine, but inside your local machine you can have three or more virtual machines. It's like a separate computers. So in the virtual machines you have a guest OS. It's like a separate OS. So assume that this is a so Windows OS is your host OS is using Windows OS, and you can have different OSs here. Like here you can use Linux, here you can use iOS, like different. So it will act as a different computers, but you are running in a single PC. In single PC you can have, you are having three virtual machines, which means three separate computer. It's like a digital version. So this is what virtual machines. So we'll see what is the advantages of Docker over virtual machines. So it requires full blown OS, which means it requires uh, yeah, whatever you are using here, right, OS. So like that it will need it. So full blown OS it's needed for a virtual machine, because it act as a separate computer, like, so that we need a separate OS. So for example, this one need 2 GB RAM, this one need 5 GB RAM, this one need 10 GB RAM, like that. So that hypervisor is a software which allocates resources, like for this guest OS allocates 2 GB, means it will allocate 2 GB RAM for this virtual machines, and for this one it will allocate according to our configuration. The hypervisor will allocate every resources from separating by interacting with host OS. Okay. So this is the answer. We see VM requires full blown OS, whereas containers share the OS. So here we need a full blown OS, whereas containers share their OS. For example, here we are using Windows OS, means so it will share the OS. So here it requires to 500 MB, means we can use only the 500 MB RAM. So according to the requirement it can use, but here we have to configure it before that, before the before it. For example, here you are running an application which requires only 1 GB RAM, but sometimes it may go down to 500 MB. So that time the virtual machine will take 1 GB RAM, because we configured with 1 GB RAM, but it requires only 500 MB. So there is a 500 MB wastage here, right? So that it will be free only. So there is a no use of it, right? We cannot use it in another virtual machine because it occupied, but your application is using only 500 MB. So 500 MB will waste only. So here, suppose here the container is requires only 450 MB means, so it requires only 450 MB. It takes only 450 MB from the host OS. So there is no wastage in that. Okay, so this is our main difference in virtual machines and Docker. And then, so that's what they are saying. Containers are more lightweight than virtual machines because it does not require any full-blown OS. It requires full-blown OS, so that it requires. So containers are more lightweight. So as their images are measured in megabytes only, their images are mostly measured in MBs, which means megabytes rather than gigabytes. But if you take a virtual machines, it requires in a GB format, like 1 GB, 2 GB, 3 GB. Okay, and then containers requires less system resources than traditional or hardware virtual machines environment, because it requires only, it shares the OS. It don't want any separate OS, right? So it requires only less system resources because they don't include operating system images, like what we see already, right? And then here we have a difference between virtual machines and containers. It's nothing but it's a heavyweight and it is a lightweight, unlimited performance, native performance, but each VM run its own OS. All containers share the OS. So here each VM run its own OS. So here you can have a Windows OS, here you can have iOS, like different OS you can have in virtual machines, but in containers you can share that OS. What the host OS is, so that OS can only can be used by the container, because here we are using iOS means the container can share only the iOS. So that is one the differentiation. And then hardware level virtualization, OS level virtualization, because the hypervisor will the software which interacts with hardware and separate allocates memory, networking, like whatever needed for OS, it will separate everything by interacting with the hardware. But here we have OS virtualization. We'll just, it's like the container runs like a software, like VS Code. So it acts as like a software. So it interacts only with OS virtualization, and the starting time in minutes, because it has a guest OS, right? So it will take some time, like minutes, 5 minutes or 2 minutes. It will take some time, but it has a lightweight, right? So it will run in a milliseconds, like just like that it will run, and allocates required memory, require less memory space. Okay, and then fully isolated and hence more secure because it runs on separate machine. So the security is more here, but here well, security is less compared to virtual machines. And we'll see Docker workflow. So we have a Docker file. For example, basically this Docker file is inside in your software folder, in your project folder. Docker file is nothing but it has a set of instructions, like what are the softwares needed to run the applications. You can copy that and you can have like a instructions, like what are the things to copy and put it in inside the container, like that. It has a set of instructions. So when you build that Docker file, you'll get a Docker image. So Docker image is nothing but it's like an instance of container. It's like a template when you build that. So here this whole process have a lot of commands. So in following session we will see how to achieve this, how to write Docker file and how to build the Docker file. So once you build image, you will get an image. So once you get an image, you will push the image to a GitHub, to a Docker Hub. It's like a Docker Hub is nothing but it's a registry where you can share your images, where you can have your images. It's like in Docker Hub you can have a registry and you can upload these images in that registry. It's like a GitHub. It's like a GitHub. In GitHub you will post, you will share their code, you will share their source code. Here we will share the images so that everyone can access it, right? So we will push, we will see how to push the images to the Docker Hub, and once you upload, once you push the Docker Hub, and how to run your application. So when you run the image, your container will get started, and inside your container, your application will get started, and you can be able to use your application. So this is what a Docker workflow. So in the following session, we will see how to how to write Docker file, how to build Docker image. So we will see step by step. Okay. So that's all. That's all today's video, guys. So if you like the video, so if you